Level 2 in Objective 24 is talking about geometric probability. So the first one we're talking about distance and length, and then the next two are talking about area. So if we read number 1, it says, suppose a point X is randomly chosen between -9 and 9, including. That means that I'm including the number 9 and including the -9 when I'm taking into account how many possible options I have here. What is the probability that X will be between -3 and 5? So if I have a number line from -9 to 9, and then I want to figure out what's the probability that it lands between -3 and 5. So remember, probability is always the amount that you want to have happen over the total amount of possibilities that could happen. So if we look at this number line, the amount of possibilities are not just -3, -4, sorry, -3, -2, -1, 0, all the way to 5. It's anywhere in between the number -3 and 5 because it could be a decimal. So what we want to do to represent the length of space between these two numbers, we're going to subtract them. Or you could really count them. 5 minus -3, which will give you 8. So this is my total amount of outcomes that I want to happen between -3 and 5. Now the total amount of outcomes you're still going to do between -9 and 9. So I'm going to do the same thing. 9 minus -9, which is 18. So then my probability would be the amount that I want to have happen, 8, over the total possible options that could happen, which is 18. And then I'm just going to simplify this into 4 over 9. Okay, so with the whole thing of length, what you want to do is you want to find the distance between your two pretty much endpoints. Okay, in number 2, it says, find the probability that a dart will land in the shaded region. So before, a couple objectives ago, we talked about and we practiced finding the area of the shaded regions. And that's going to come in handy in this problem here. So if we look at A, I want, again, the probability that's going to land in the shaded region. So that's my desired outcome. That's what I want to have happen. So to find my probability, I'm going to say area of shaded over area of total. So if I find the area of the shaded, I'm going to find the area of the rectangle and subtract the area of two circles. So it's all about having a plan for the shaded regions. So the area of the rectangle and the area of the circles, that's what you need to figure out. And then the total is just going to be the area of the rectangle again. Okay, so if I look at this picture here, I have the whole width of the rectangle to be 20. That means each circle has a diameter of 10 or a radius of 5. And if they each have a radius of 5, that means the height of this rectangle is going to be 10. So the area of the rectangle is going to be 200. The area of two circles, well, one circle will be 25 pi. And I'll put that over 200. So if I simplify this, it's going to be 200 minus 50 pi over 200. Okay. Now remember, you can simplify this, so you just got to make sure that every single term can be simplified by the same number. So between 200, 50, and 200, the number that goes into all three of those is 50. So if I divide 200 by 50, that's going to be 4. 50 pi divided by 50 is just pi. And then 200 divided by 4 is 4. So this is your probability right here. 4 minus pi over 4 would be the probability that it's going to land in the shaded region. Let's practice one more. In B here, we got a circle with two circles inside. We want to find the probability that it's going to land in the shaded region. So again, here's our plan. We want to find the area of the shaded over the area of the total. So to find the shaded, we're going to find the area of the large circle minus the area of the two small circles. And then over the area of the large circle. Okay, So we've got the area of the large circle. We first have to find out the radius of the large circle. If I'm given the two radii of the smaller circle to be 3 and 2, that means their diameters are going to be 6 and 4. So those two diameters together equal the diameter of the whole large circle. So if the diameter of the large circle is 10, that means the radius is 5. So my area of the large circle is going to be 5 squared pi minus the area of the small circle, so that'd be 9 pi and 4 pi. Just change this here right away, so this is going to be 25. And it's going to be 4 pi. And then over the area of the large circle, which we said was 25 pi. And then from here, it's just simplifying. So 25 minus 9 minus 4 is going to be 12 pi over 25. And 12 and 25 have no common factors, but if I have a pi in the top and a pi in the bottom, those are going to cancel out. I'm just going to be left with 12 over 25. So 12 chances out of 25 times it will land in the shaded region.